third edition of Math for No Reason. In this edition, we will prove this famous identity that NC0 plus NC1 right up to NCn is equal to 2 power n. Here, of course, n is a natural number. Now, how do you prove that? There are many proofs of this result. One very famous proof uses the binomial theorem. However, we will give a different proof of this result using induction. So let n be equal to 1. Now for n is equal to 1, we have 1c0 plus 1c1 on the left hand side, which is equal to 2, and that is equal to 2 power 1. So therefore the left hand side is equal to the right hand side. As the next step, let us assume that the result is true for n is equal to k, and we will then try to prove this for n is equal to k plus 1. Now since the result is true for n is equal to k, so we have that. Now we note that if the result is to be true for n is equal to k plus 1, then the answer should come as 2 to the power k plus 1. And that gives us an idea. And the idea is that why don't we add the same series twice? Now once we add these two, what we get is, now kc0 is 1, so we can write this as k plus 1 c0. K plus 1 c0 is also 1, and we note that kc1 plus kc0 is nothing but k plus 1 c1. Similarly, kc2 plus kc1 is k plus 1 c2, and so on. We get k plus 1 ck, and finally we will write kck, which is 1, as k plus 1 ck plus 1, and that is equal to 2 to the power k plus 1. Thus we see that the result is true for n is equal to k plus 1. Hence, by the principle of mathematical induction, the result is true for all n. One way of interpreting this is that we can think of all the subsets of a set with n distinct elements. Any subset of a set with n distinct elements will either contain 0 element or 1 element or 2 element up to n element, and there will be NC0 subsets containing 0 element, which is 1, and the null set is the only such set, or NC1 sets containing 1 element, or NC2 set containing 2 element, etc. up to say NCn-1 sets with n-1 elements and NCn sets with n elements. So the sum on this left hand side is nothing but the number of subsets of a set with n distinct elements, the so-called power set. Now this result tells us that the power set of a set with n distinct elements will have 2 power n elements. So the cardinality of the power set will be 2 power n. This is a good point to stop. Thank you.